In the last few videos, I'll walk through each of the parts of question number 5, which is giving you a recursive definition and asking you to test whether the definition is true or not. You may find that after just one of these examples, you totally understand and you don't need to watch the rest of the videos to get the rest. So I'll leave it up to you to decide for yourself, as always, whether watching all of the videos is necessary or whether you can kind of cut things short and figure things out on your own. I trust that you'll make that decision for yourself as you go through each part. Now, let's take a look, if we can, at question letter A. It says in the instructions, we're trying to determine whether this is a true or a false statement. True or false implies either that the direction or that the definition is correctly written, that it does refer correctly to the pattern in the table, or false if something about the definition just doesn't seem right, if something seems off based on the way the equation looks. So because with all of these questions, I want to make sure I have an accurate table to follow or to use as reference, let's quickly fill in the missing numbers in the table. I know that this is a geometric sequence because it says in the question the word geometric. So geometric means we have a multiplication pattern. And even though there are a few ways I can get from 2 to 4, I need to think only about a way of multiplying. What's a multiplier that can get me from 2 to 4? Well, I know that 2 times 2 is 4, so that must be the multiplier. The multiplier must be times 2. So 4 times 2 would be 8. 8 times 2 would be 16, so we know that works. 16 times 2 would be 32. 32 times 2 is 64, and 64 times 2 is 128. So it looks like the pattern does indeed seem to be pretty straightforward. Now the only thing missing is this initial value here, so something times 2 must have given me this 2 that they initially gave us, and we can work backwards and either divide, or we can just use common sense and say, well, 1 times 2 is 2, and so now we have the full pattern. So let's look at letter A now that we know the full pattern, and let's see if the equation that they give us makes sense. The definition really does have two parts. The first part is supposed to be a specific term in the sequence. So that's what I'm looking for first. Is this really referring to a specific term that we know for sure is accurate? And the second part is the part that tells us how to get the next term. The T of n plus 1, remember, is that code for saying what comes next, like we talked about in the previous video. So let's first check. This definition claims that t of 0 equals 1, that the 0 term is 1. Let's check the table. Is the 0 term 1? Yep, it looks like that checks out. Now I don't want to immediately circle true because I've only checked half of what they gave us, but that's one of the things I want to check. Are they giving me a specific term that really is part of the pattern? That one is, so check. Now, let's see if this accurately describes what to get next. If I translate this statement, it says to get to the next term, I do 2 times the current term. Remember, T of n is kind of like saying where you are currently. To get to the next term, you do 2 times the current term. Well, that sounds like it makes sense. I mean, that sounds right, but sometimes it's hard to tell. So let's test our equation. Let's test our equation with something we know, and let's see if it actually does work mathematically. Now we know n is 0. They gave us that, n is 0. So let's use what they gave us, n equals 0, because they told us the 0 term. Let's assume they told us something that they're saying, hey, this is factual. That means I can test my equation by plugging 0 in where I have the letter n. So t of 0 plus 1 equals 2 times t of, again, 0. Now I'm going to think about what this means. T of 0 plus 1, well, 0 plus 1 is just 1, equals, and then I have 2 times t of 0. Well, t of 0, we already said, is 1. I can do a little substitution here. T of 0 is just 1. So now what I'm writing is t of 1, because remember 0 plus 1, is equal to 2. And now I should check my table again. Is that true? T of 1 is equal to 2? Yeah, that is true. T of 1 is equal to 2. So it seems like the specific term they gave me checked out. And when I plugged that specific term into the equation in the second part, that also checked out. So it seems as though I have a true statement, because both of the parts that they gave me really did check out. See if you can understand why we reached that conclusion, why we knew the specific term was true, and why we tested the equation the way we did. Once you understand how this one works, you'll apply the exact same logic in letters B and C. If you understand it well enough, then you don't have to watch the videos for B and C. But if you feel like you need to, stay tuned and we'll walk through each example together.